In this tutorial, we will discuss a review of oxidation and reduction. In electrochemical reactions, electrons are transferred from one species to another. In order to keep track of what loses electrons and what gains them, we assign oxidation numbers. A species is oxidized when it loses electrons. Let's look at zinc. Zinc goes from a 0 to a +2. It is being oxidized because of the fact that it's losing electrons. Remember, electrons are a -1 charge. So if we lose electrons, we're losing -1s. So that actually turned into a more positive charge. I remember oxidized by the phrase LEO. Lose electrons, oxidized. A species is reduced when it gains electrons. Here, it's going from a +1 to a 0. Each hydrogen gains an electron and they combine to form H2. I remember reduced by the phrase GER. Gain electrons, reduced. So if we put it together, LEO GER. Lose electrons, oxidized. Gain electrons, reduced. What is reduced is called the oxidizing agent. H+ oxidizes the zinc by taking its electrons. What is oxidized is the reducing agent. Zinc reduces hydrogen by giving its electrons. As we've stated several times now, we keep track of what's going on by looking at the oxidation numbers. There's a set of rules to assign these oxidation numbers, and we're going to go over them right now. Once again, this should be a review of something you've had before. Elements in their elemental form, so not bonded to anything else and not as an ion, have an oxidation number of 0. The oxidation number of a monatomic ion is the same as its charge. So if we look at Na+ or Cl-, their charges are the oxidation number of that ion. Nonmetals tend to have negative oxidation numbers, although some are positive in certain compounds or ions. Oxygen has an oxidation number of -2. Except in peroxide ion, which it has an oxidation number of -1. Hydrogen is -1 when bonded to a metal and +1 when bonded to a nonmetal. Nonmetals tend to have negative oxidation numbers, although some are positive in certain compounds or ions. Fluorine always has an oxidation number of -1. The other halogens have oxidation numbers of -1 when they are negative. They can have positive oxidation numbers, however, most notably in oxyanions. The sum of the oxidation numbers in a neutral compound is 0. The sum of the oxidation number in a polyatomic ion is the charge of the ion. Alright, so let's take a second to practice these. Bromine, since it's in its elemental form, is 0. Potassium, since it has a +1 charge as the ion, its oxidation number is +1. Lithium fluoride. Fluorine is always -1, which automatically means lithium is a +1. D, E, and F are a little bit more difficult. So, carbon is what we're going to try to find out. According to our rules, oxygen is always a -2. So we have 2 times -2, because we have 2 oxygens times the charge of oxygen, which is -2. It's a neutral atom, so it's going to equal 0. That means oxygen is a -2. That carbon then must be a +4. The next one, sulfate. We have 1 sulfur and 4 oxygen. Once again, oxygen is a -2. All together is going to equal -2. So S minus 8 is equal to negative 2. That means sulfur must equal a positive 6. And finally, sodium peroxide. This is the peroxide. O2 is peroxide. So 2 times plus 1 plus 2 times negative 1 is going to equal 0. So oxygen is a minus 1 and sodium is a plus 1. Assign oxidation states, determine the elements that are oxidized and reduced, and determine the oxidizing agent and the reducing agent of the following. Alright, so let's match up our atoms here. 10 is going from a plus 4 to a plus 2. I like to look at the number line if I'm just beginning. So plus 1, plus 2, plus 3, plus 4, we'll go up to plus 5. Okay. 10 is starting at a positive 4 and it's going down to a positive 2. Even though it's not in the negative range yet, it's becoming more negative. So that means it is gaining electrons. In fact, it's gaining 2 electrons, which means Leo, gain electrons reduced. And by definition, if it's reduced, that means it must be the oxidizing agent. Calcium is starting off at a 0 and going to a positive 2. So here's 0 on the number line. It's going to a positive 2. It's becoming less negative. It's losing electrons. In fact, once again, it lost 2 electrons. Which means Leo, lose electrons, oxidized. So that means this is oxidized. If it's oxidized, that means it must be the reducing agent. And that is your quick review on redox reactions.